Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers turned podcast. Everyone, welcome into the program. Today on the show, we have the one, the only Mr. Ralph Bond. He's on every Friday. He is our science and tech trends correspondent. If you'd like to know more about that, you can check out our site. We have a full write-up of him. And of course, hey, we have links to his site in the show notes. Those are going to be super important. We have links to everything that we're going to talk about, including Ralph's website and all the stories, videos, articles, all that kind of thing. So everyone, I hope that you're having a wonderful Friday, and we really enjoy doing these things on Friday because, hey, it's we end the week on a little bit of a lighter note. So before we get started, computeramerica.com, that's where you'll find everything, including past shows, future shows, podcasts, articles, reviews, topics, events, social media links, everyone, giveaways. You can find all that there at our website. I apologize beforehand. We're having a little bit of trouble. Something about web developer and, kind of the back end of the whole thing. So if you're having trouble, please just bear with us for a couple of days. We're going to try to resolve this over the weekend. But let me just say that next to audio issues, troubleshooting websites is one of the worst things in the world. So, but that's neither here nor there. The website works. You should be able to get the show links. Everything should be just fine. But everyone, computeramerica.com, let's go ahead and bring Ralph on. So joining us today is, as I said before, Ralph Bond, our science and tech trends correspondent. He is also the tech insider for the Mark Mason Show at KEX Portland, Oregon. And of course, longtime Computer America correspondent. Ralph, welcome back. How you doing?
Hey, it's great to be back, Ben. And I'll tell you what, in this age and time of such terrible, sad news, you and I each Friday get to bring some, well, I hope, joy and happiness through some exciting science and technology stories.
Ralph, I don't care what they say. You do that to me. So you know what? I really enjoy these segments. So no, you're absolutely right. And, just thumbing through the articles, we have the first one there, but, we have things like scientists are able to resurrect dead cells. They're, little tiny baby walking robots, not going to give away all of it, but yeah, you come up with quite a mix. What do you go for?
Yeah, well, I'll give my little spiel about what I do. So, Ben, I'm an aggregator of science and tech news features. I find monitoring a host of online outlets, and I look for important and sometimes wacky and out there stories that don't usually capture mainstream press attention really often at all. Of course, unfortunately, our mainstream press, sad to say, is involved with school shootings and other things like that. Oh, goodness. But anyway, I'm always on the lookout for news that gives a glimpse into where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. And what I do with each news item is present the essential points and in a digestible form. And I stress to our audience to check out the show notes you mentioned that you post on your site with links to the articles, pictures, all this sort of stuff, because we're just going to give you the greatest hits of each story. If you want to get into the science and technology of each story, please get the show notes. Please check out those links and read those articles in full.
You should definitely do that. And of course, if you're watching the video component, we're going to show videos in the articles. But yeah, everyone, if you are just listening to the audio portion, hey, that's perfectly fine too. And we look forward to this. So everyone, let's go ahead and get things started with story number 1.
Yes, this is a great one from Smithsonian Magazine. And it's a good example of what we were just saying. Kind of cool, kind of neat. I understand why the big mainstream press wouldn't pick up on this story necessarily, but it's really neat stuff. So the headline here is scientists recently mapped Yellowstone's underground plumbing. And so scientists have long wanted to understand what the heck's going on deep beneath the amazing natural wonders of Yellowstone National Park, such as the stunning geyser Old Faithful. And I've been there, which is a wonderful place. So recently, using a helicopter equipped with an 80-foot diameter, hexagon-shaped electromagnetic ring dangling underneath, U.S. Geological Survey researchers mapped the Earth below Yellowstone as far as 8,200 feet deep. And folks, that's about 1.5 miles. Think about that. Yeah. Wow. And you're able to show our listeners and viewers the photo of the helicopter with this device hanging down there. My gosh, that thing's an 80-foot huge. Anyway, so the hexagon-shaped electromagnetic ring sent out electromagnetic pulses that traveled below the surface and bounced back up again, similar to a radar signal. And after analyzing the data gathered, the U.S. Geological Survey researchers gained an accurate and detailed deep underground picture of the rocks, clay, and thermal liquid below Yellowstone. And in the show notes and so forth, there's that chart, very colorful chart that is exactly what they're talking about, this map, if you will, of the underground area. And so scientists, they're beginning to explore the underground survey results, and already they've discovered one new mystery. Old Faithful and the Upper Geyser Basin, they're 6 miles apart, but they appear to share the same hydrothermal source below the surface. So that's just one discovery. I'm sure many, many more will follow. And in addition to breakthrough geological knowledge, like we just mentioned, this new data will also help scientists learn more about the tiny microbes that can survive in Yellowstone's scalding hot springs. I still blows my mind. I remember when we were visiting the site in Yellowstone and learning about this and thinking, how in the world can these little critters live? The microbes live in that kind of condition. But this data will also help in the exploration of how that's possible. It's really amazing. I digress for a second. One of the things that I recall scientists being so excited about these microbes in these terribly hot water situations at Yellowstone and elsewhere too, is that this could indicate the possibility on other planets in the Milky Way and whatever other planets that have very hot situations that might have hot water, that it's possible for life to exist in those kinds of conditions. So that's a kind of side note on this story that I always think about as sort of interesting.
Right. Yeah. It's always, at least here on Earth, the most inhospitable, the worst places to live on Earth.
Yes.
Scientists go there, they go to the Antarctic, they go underneath the ice sheet, they, find little microbes near thermal vents that haven't seen sunlight in 10,000 years. Ralph, I know that everyone wants Steve from Mars to show up, a full-fledged alien that we can all interact with and it'll be a great time. But you're right. Yeah, this is what aliens are potentially going to look like. And hey, at least here on Earth, life is a lot harder than we kind of thought. Where it's there's a good possibility. So I think that's why we also cover a lot of landers and rovers and kind of flyby missions to Mars and I'm trying to think of Saturn's moon. That's is it Europa? I think it's Europa. That moon that could potentially have life. Things like those, really, really exciting. But that aside, this whole Yellowstone thing, I hope they just find out that it's not going to explode. That's really, I feel like, a lot of people's big concern with Yellowstone.
Yeah. You're right. Hopefully this, that's a really good point. It wasn't, I don't believe it was in the article, but hopefully this research will help kind of give them a better ability to monitor potential problem areas. Yeah. That's interesting.
Well, and then of course we're going to move on to story 2, but my only thinking is that if they kind of map because a lot of this is from the magma underneath the earth and the heat and all that kind of thing. I'm wondering if they can kind of pick up, where the chambers are by mapping them, put sensors somewhere near the chambers and be like, hey, we're going to know explosions before, eruptions before they happen. So fingers crossed. To your point, if they periodically did this flyover with the helicopter and this device, maybe once a year, and they can compare to see, there's a difference here in this underground feature. It's expanding, or it's what? Yeah, you make a good point. Yeah, that's interesting. Maybe eventually we'll learn exactly when Old Faithful's going to go off next. That's
maybe.
Maybe we'll get there. So that's story number 1. Story number 2 is, kind of the whole resurrection thing I was talking about. And this should be, hopefully very compelling research for those who have unfortunately lost vision.
Oh, yeah. This comes from futurism.com, a wonderful site, by the way. Headline here is International Team of Scientists claims they can bring dead human eye cells back to life. Wow. Irresistible headline. A team of researchers from Switzerland and the US recently announced they woke up light sensing cells from eyes harvested from human organ donors 5 hours after death.
Wow.
And then this is a breakthrough that could potentially allow scientists to extend the shelf life of donor organs and lead to new ways to treat eye diseases. I mean, this just hits it right out of the park. I love this. In specific, The team claims they got retinal neuron cells to communicate with each other post-mortem and were able to wake up photoreceptor cells in the human macula, which is the part of the retina responsible for our central vision and our ability to see fine detail and color. So in eyes obtained, again, up to 5 hours after the organ donor's death, these cells responded to bright light, colored lights, and even very dim flashes of light. And the team believes they may be able to use this research to reverse some types of blindness. And this is a good example, by the way, Ben, of what we said at the outset. Go to the show notes, get to the link, read the entire article. I'm giving you the highlights. More about the science, more about what they did is you'll find in the article. So please do go check that out if this is of interest to you. And I think everybody that has eyes should be interested in this story.
Yeah, there's definitely a lot of different avenues in research when it comes to eyes. I know that whenever there's an accident happens, Ralph, and they someone's an organ donor, which by the way, everyone should be an organ donor.
I am.
Same here. I know that they harness the retinas, because then they can transplant those to recipients and restore vision that way. But right. I guess with this kind of research, in those cases where they normally just get the retina, they would get the entire eye, and people could potentially get complete vision back that had a lot of different problems. Like what I'm saying is we're already kind of harvesting this kind of area when someone unfortunately passes. It's just that when they're dead, the eye's useless. So this hopefully a lot more donors and a lot more donors organs can reach people who need them. This is perfect. Just kind of using more of what we already have.
Yeah. And I want to stress something that was said in passing here earlier that's important. This is not just exclusively potentially applicable to eye cells. Remember there's the line in the story here, a breakthrough that could potentially allow scientists, to extend the shelf life of donor organs. So this research for the eyes could be applied, we hope, for other body part donations, as it were. The potential here is significant, to say the least. Just in our personal life, we've had a lot of cancer diagnosis in the last couple of years, in the last year or so, because I think when COVID happened, Ralph, a lot of people, kind of skipped their regular doctor appointment, the healthcare. Oh, yeah, right.
Just everything was so flooded. People are getting back. They're doing their screenings, which everyone should. And unfortunately, it's kind of showing that, skipping a year or two really has an effect.
Yes.
And I'm hoping that, maybe in the future, we can just kind of swap out whole organs. Like, you have liver cancer? Well, here, slap a new liver in there and you're good to go for another, 20, 30 years. There's a lot of possibilities, and all of them are better for humanity. So I love that kind of story. Story number 2, perfect. Story number 3, this one, now, I have a problem with this one, Ralph, because I have a very basic understanding, and I'm very committed to that very basic understanding. You are challenging what a silicon and a semiconductor a transistor can really be. And I don't know if I like that. So, story number 3.
It's not me. I'm just the vessel reporting.
You are the messenger, so therefore you must be, yes. So, okay, story number 3, let's go ahead.
Yeah. And by the way, story number 3 involves graphene. And a lot of people I know kind of roll their eyes whenever they hear these graphene stories, because it's sort of like this is wonder material that can do everything for everybody all the time. But with that said, here's the headline.
The joke is, and Ralph, the joke is that graphene can do anything but leave the lab.
I love that. I'm going to remember that. So this story I got from gizmodo.com, and it's picked up elsewhere too. Scientists announced a non-silicon transistor, which they claim should allow semiconductors to keep getting smaller. In other words, to extend the life of Moore's law, if you're familiar with that. But now for your audience, probably this first part here is not necessary, but I felt I need to do this in case, someone in the audience is not fully up to speed on this. So first we need to set the stage for this news. So some fundamentals here. A transistor is a binary on-off switch and the fundamental building block of today's chips, of course, which are small pieces of silicon containing integrated circuits made with transistors, right? Okay, today's electronics and computers, our cars, smart TVs, smartphones, appliances, you name it, have silicon chips with millions or even billions of transistors. And the drive to make transistors smaller and to pack more on chips to boost performance, I think everybody's aware of this, with some transistors measuring only a few billionths of a meter wide, unbelievable, presents a serious challenge with energy consumption, heat, and limits on total chip size. This is what Intel and all AMD, all these people are constantly battling every single day in their research labs. So with the growing demand for faster and smaller electronics, no surprise, engineers are facing a real dilemma. I might say a kind of a potential brick wall, if you will.
Oh, yeah.
Well, here's the latest twist on this. A team of researchers from the University of Buffalo and the University of Nebraska-Lincoln now want to turn the industry upside down with a design for non-silicon, graphene-based transistors, which should allow transistors to keep getting smaller, so they say in their research. Here's what makes their approach totally different from today's silicon transistors. Current silicon transistors typically compute by pushing electrons through a gate. When the electrons are flowing through the gate, it represents a 1 in binary code. And when they're not, it's a 0. And if you're familiar with binary code and all that good stuff, this makes sense. The research team says their non-silicon, graphene-based transistor design relies instead, I think this is kind of interesting, instead on the spin of electrons instead of their flow. And electrons can spin in one of two directions, up or down. Who knew? The research team's revolutionary 2-layer transistor starts with a layer of graphene that electrons can flow through. Underneath the layer of graphene, the designers placed a layer of chromium oxide. Stay with me. This starts making more sense. When a positive voltage is applied to the experimental graphene transistor, the electrons in the chromium oxide layer spin upwards. And as a result, the electrons in the graphene layer veer to the left. Freaky weird. When a negative voltage is applied, the electrons in the chromium oxide layer spin down, and the electrons in the graphene layer veer to the right. So here's the deal. This left and right movement of the graphene electrons creates easy to detect signals that can correspond to the ones and zeros of computer binary code. And the researchers claim their graphene-based transistors would also make electronics run cooler and may help cut global digital energy consumption. So this is very geeky, very techie story. Please go get the link if you want to dive in deeper on this. But that's sort of fun about the veering left and veering right of the electrons being a new way, and how that it's not entirely clear to me how this helps transistors become ever and ever more smaller than current technology would allow. But nonetheless, it's just sort of an interesting twist. And I also think the fun part of this story too is it's no dig against the University of Buffalo or the University of Nebraska-Lincoln, but they're not the kind of thing that comes to mind when you think of, say, Northwestern University or Stanford or MIT or whatever. But God bless them. I think this is awesome that these two institutions that you normally don't think of right off the top are really doing this kind of amazing research. So good for them.
I'm sure that when people think of the University of Nebraska, maybe corn-related studies would be, kind of the first thing that comes up. I actually had that once, Ralph, where there was a PC manufacturer. I think it was like Falcon Northwest or something like that. But anyways, it was a PC manufacturer. And, when we talk to these guys, we'll be like, where are you based? And they'll be like in Miami and New York, San Francisco.
Yeah.
We'll be based in Austin, Texas. These kinds of places. We did have one that was like, oh, we're in Nebraska. I was like, what?
Yeah.
Like, oh yeah, land's very cheap out here. I'm like, yeah. You can ship everywhere, and you're right in the middle of the country. So, by the way, for everyone out there, and you mentioned Moore's law, and kind of in passing, I'm always reminded of kind of this the scene from Monty Python with, I believe it's Sir Lancelot attacking the castle. That's essentially what Moore's law is, where it's this thing that kind of keeps on almost being here, almost coming, but of course it hasn't been here yet, Ralph. We've always been able to stay ahead of Moore's law, and it's and actually we've been able to speed it up, so things like that. So,
yeah
But of course, the joke only works if we stop the video before Lancelot actually reaches the castle. So, with that being said, this is very cool. And again, just being able to make the stuff out of these different materials makes, I guess that definitely makes it different. It's just, Ralph, you have a history with Intel. I think everyone out there who's really into computers is kind of very familiar with, the single sheet of carbon atoms that, kind of everything is kind of made out of, or at least, the close enough to it. Making everything out of graphene, Ralph, I think it would make everything better. I know it would make everything better. It's just, man, when is graphene going to get here? It's
well, and to your point, this research is all well and good. Can they translate this? It may physically beat traditional silicon transistors right now, but can you make it practical? Can you make it cost effective? Can you make it less expensive? If you can make this less expensive and really real world deployable, and achieve the kind of goals that they say they potentially can do with these new graphene based transistors, then that's revolutionary. But often, and I'm sure your experience too, is the ideas work, the science works, but then when you try to go to the real world, the cost or manufacturing issues or other things of this nature make it like, well, it's neat, you can do this, guys, but we can't make it real in the terms of the real reality of the economy. I don't know. You just have to wait and see. But it's just that story just really resonated with me.
We've been talking about the death of the lithium-ion battery for about 30 years now. So, I think a lot of people are very familiar with technological promises and how we're going to move on to something better. But honestly, everyone, we have some pretty good stuff now. Like, it's a pretty good time to be into computers. Things are running good. But hey, thanks to Nebraska, and I never thought I'd say this, we're looking for something better. So there you go.
Yay.
There you go. So story number 3, story number 4. And this picture really puts it into perspective. So if you're watching the video portion, highly encourage that. But Ralph, this is offbeat. It's on beat, but it's also off. Offbeat. So let's talk about this.
Yeah. It's hilarious. I love this. And actually, the inventors of this technology claim it could have some real world applications. We'll get to that in a second. So headline here is engineers invent the world's smallest remote controlled walking robot. Pick this up from CNN, and you can find other coverage of this and videos and so forth on the web, of course. So engineers at Northwestern University recently announced the world's smallest remote controlled walking robot. And if you're looking at the pictures, it's just hilarious. So each one of the tiny robots, which looks like a crab or a spider, really more like a crab with multiple legs, because in the video you're showing, you can actually see the little pincers, little arms with the grabbing things, is about 0.5 millimeter wide, which is smaller than the thickness of a United States penny. So there's a picture where they show one of these little robots on the edge of a penny, and you can see how tiny these things are. The robots, which are made with a malleable shape memory alloy, start out as flat objects similar to like a piece of paper. Then the legs and arms are bent so the robot can stand, and the crab-like robot stays standing on its legs until heat. This is so odd and interesting. Until heat from lasers is used to start the robot walking. So the bottom line is you think, well, is this just a fun stunt? Is it just sort of like some research project a graduate student did just I don't know, for fun? No. The researchers say the tiny crab robots could be used in performing minimally invasive surgeries. That's something to wonder about. Or aid in the assembly and repair of ultra small scale machines. My question there for that conclusion that they offer is, how those little pincer arms, are they really, can you move them? Can you grab stuff? Because that part would have to be in order for them to do things like minimally invasive surgeries or aid in the assembly and repair of ultra small machines. So maybe this prototype has limited mobility or limited appendage workings, TBD, but the possibility here is kind of fun. But the part that really, really caught my attention is using heat from lasers to make this thing move. Right. That I would love to learn more about. That's bizarre, I think.
Definitely seeing these things move, very, like they said in the article, similar to pop-up book mechanics. So it's more just the constant flexing of these legs that kind of move it. Ralph, to your point, I don't think, and just from the pictures that we're seeing and kind of looking here,
right.
I think they purposely made it, because I'm sure they had to print all these little pieces. I'm sure that they, instead of just doing 4 legs, some pioneering research student did 4 legs and 2 claws and assembled all of these, kind of by hand, just because they do look like little crabs, or of course I'm from Florida, so the little spider crabs that everyone is very familiar with. They're very cute. I think right now the application is kind of like where, but you can see here the locomotion is fairly complex for something that has no real hardware. It's very, very cool.
Yeah. I think to your point, Ben, these little guys themselves may or may not be that world practical, but the technology, the understanding, the knowledge could be applied to do something that could be. So, it's a wait and see deal on this one.
Oh, while I'm not the most up to date on academia, I'm sure that someone somewhere out there chased down a lot of research 50 years ago, and then it was revisited after 45, 50 years, and, hey, it actually has some actual practical application. So someone else can, of course, now build upon this. And this is very, very cool. And I got to say, very, very cute. The fact that the video says these things are smaller than a flea, I think that kind of gives people another example.
Good one.
Right at the beginning of the video, it kind of mentions that these things are the smallest remote control walking robot, and they are smaller than a flea. There you go, right there. So that's my source. Very cool, Ralph. And I think with that, we're going to go ahead and kind of call that a show because, man, we got through all the stories. Ladies and gentlemen, if you remember yesteryear, we used to never get through all the stories. But here's the thing. If you want more Ralph, if you crave that homework that we used to give you, well, go on over to Ralph's site, go on over to our YouTube channel. We have an All Ralph section. And of course, at his website, we have past shows that obviously with these stories, hey, they're timeless, at least for a couple of years. So, plenty of watching. Ralph, I hope that you have a great weekend. Everyone else out there, I hope you have a fantastic weekend as well. And join us back here next Monday for more Computer America. So until then, have a great day. Thank you so much. Bye, everyone.